Hello class. Today we are going to cover 3.5 complex numbers. This is going to be a very quick video. We introduce complex numbers here so that when we go back to talking about higher degree polynomials and the zeros of them, now we can look at the imaginary ones as well. Okay. All right, so 3.5 complex numbers. So because you're in pre-calculus, I'm guessing you're all pretty familiar with complex numbers. Okay. All right. So this is what a complex number looks like. And this is going to be the standard form. So it has this form a plus bi. Okay. So this is your standard form, and it's made up of two parts. This part here, which is the real part, and this part over here, which is the imaginary part. Okay, so this is standard form. So if you have something that's written like this, let me give you an example. So if you have 3 plus 5i over 2, this is not in standard form because here it's not written in the two parts, the real part and the imaginary part. So here you would have to separate them and say 3 over 2 plus 5 over 2i. That way you can identify the real part and the imaginary part and what the a part is, what the b is. Okay? And imaginary numbers, that would be I. And we know that I is equal to the square root of -1. Okay. And if I square that, if I square both sides, then I get I squared on the left, and I get -1 on the right. Okay. So we see that I squared is equivalent to -1, and hopefully you guys looked at I to the third and I to the fourth, and just knowing those four will allow you to find or evaluate higher powers of I, like I to the 87th power. Okay. All right. So if I have to simplify square root of -4, okay, then here, this would be equivalent to 2i. If I have square root of -100, that would be 10i. Okay. All right, so adding and subtracting. All of the operations are pretty intuitive, with the exception of division. That is a lot more like rationalizing the denominator when we were looking at radicals. Okay, so let's start off with addition and subtraction. Okay, so if I have this complex number, 4 plus 5i, and I want to add it with this complex number, -7 minus 2i, then I can go ahead and remove the parentheses. Okay, and I can combine the real parts together, and I would get -3. Okay, the real part being 4 and -7. Okay, so it's almost like combining like terms. Okay, so, and then I would combine the imaginary parts, 5 and -2. 5i and negative 2i. Okay, so this is what we would get. Okay, and same thing with subtraction. Suppose that you have this complex number, 6 minus 3i, and you are going to subtract negative 2 plus 4i. Okay, again, I can remove my parentheses. When I do that, this subtraction will get distributed to the negative 2 plus 4i, so that will become a positive 2 and a negative 4i. Okay, and so I will add the real parts together. I get 8, and I will combine the negative part of the imaginary parts together, negative 3i and negative 4i, and that's what we would get. Okay, so that's adding and subtracting. Let's take a look at multiplication. Okay, so the one thing you have to kind of remember is that I squared is negative 1. Okay. All right, so suppose that I want to multiply this complex number, 3 plus 2i, with this complex number, 3 minus 5i. Okay, so you FOIL this out, you do your distributive property, just like if you had a binomial times binomial. So I'm going to go ahead and do 3 times 3 and 3 times negative 5i. And then I'm going to do 2i times 3 and 2i times negative 5i is going to be negative 10i squared. But remember, we said I squared is negative 1. So this becomes 9. And I'm going to combine like terms. So these two right over here. So that's going to give me negative 9i. And then this here, that I squared is a negative 1. So then this negative 10 becomes positive 10. So my final answer, real part 19, imaginary part this. Okay. So that's all for multiplication. You multiply as usual. The only thing you have to kind of remember is this part right here, that I squared equals negative 1. Okay, so let's take a look at division. Okay, suppose that I have this complex number divided by this complex number. Okay, so over here, what we're going to do is kind of like the equivalent of when you had radicals in the denominator. Do you remember that? And we rationalized. Okay, so that's what we're going to do here. So here, we're going to multiply by the conjugate of denominator. Over itself, okay? Because we can only multiply by the number 1, or else we change the value of this number. So we're going to multiply by the conjugate of the denominator over itself, okay? So 4 minus 3i is the denominator, right? Here I'm going to bring the problem down here and work it out. Okay, so 4 minus 3i is the denominator. So what I'm going to do is I'm going to multiply the numerator and the denominator by the conjugate of 4 minus 3i. So that's going to be 4 plus 3i over itself, which is essentially 1. Anything over itself is 1, almost. Okay. All right, so let me get my black pen back. All right, so here we'll distribute across the numerators. 3 times 4 is 12. 3 times 3 is 9. And then negative 2i times 4 is negative 8i. And negative 2i times 3i is negative 6i squared. Okay, and then down below, there's a bit of a shortcut, but if you don't see it, because here, let me just go off to the side. Here, if you multiply conjugates, right, you'll get difference of squares. Do you remember that? You're used to going backwards. You're used to going, having the difference of two squares and then factoring it, right? But it works both ways. If you have these to multiply, you're going to get your difference of squares. If you have your difference of squares, then you're going to factor it to that, okay? So that's what we have here. So I am going to get difference of squares. So I'm going to get 4 squared minus 3i squared, okay? So in the numerator, I squared is negative 1, so that's going to turn into a positive 6. And I'm going to combine that with this 12. So I'm going to get 18. Okay. And then positive 9i and negative 8i is 1i. And then down below, I get 16 minus 9i squared. I squared is negative 1, so that'll turn into a positive 9. So I end up with positive 9 and 16 is 25. I'm going to go ahead and separate them right now to get my standard form. And there's my imaginary part. Okay. So hopefully you understand this part over here. Okay. If you didn't understand that part and how I got this denominator here, then just go ahead and work this out. 4 times 4, 4 times 3. And then do negative 3i times 4, negative 3i times 3i. You'll get the same answer. Okay. It's just if there are shortcuts, then why not use them? Especially if they were shortcuts you learned in previous math classes. Okay. So we cover complex numbers here in the middle of doing all these things with higher degree polynomials, because now instead of getting the question or the direction to find all the real zeros or find all the rational zeros, now it's just going to say just find all the zeros. Okay. So this is going to be all the real ones and all the imaginary. Okay. So like, for example, here, suppose that we have this x squared minus 4x plus 5 equals 0. Okay, so even if you try to factor this, it's not going to work. X, both signs have to be the same, both negative. There's only one way to make 5, so 1 times 5, and that's not going to give me negative 4. So this here tells me it is not factorable. Okay, but it is a degree 2, so I can use quadratic formula. Okay, so I'm going to use quadratic formula on this quadratic where a is 1, b is -4, and c is 5. Okay, so quadratic formula on this. So x equals -b plus or minus the square root b squared minus 4ac all over 2a. Okay, so that's +4 plus or minus. That's going to be 16 minus 20 all over 2. Okay, that's going to be 4 plus or minus square root of -4 all over 2. Square root of a negative number will be imaginary. So that's going to be 4 plus or minus 2i over 2. Factor out a 2 from the numerator. And when I factor that out, I can cancel it. Okay, and so there are my answers. X equals 2 plus I, and x equals 2 minus I. Okay, so these are my two solutions. Okay, so you're going to be asked to find all the solutions, all the zeros, not just the real ones now. So you have to find all of them, real and imaginary. Okay, all right, if you have any questions, make sure you email me. Make sure you keep up with the homework. That's going to be the most important thing you do in order to do well in this class. Okay, so keep up with the homework. Email me, Zoom with me, text me if you have any questions or if you need additional help. Okay.